Today we will be solving Leetcode 74. In the problem statement, we have been given write an efficient algorithm that searches for a value target in a m multiplied by n integer matrix. The matrix has the following properties. Integers of each row are sorted from left to right. So from left to right, every value has been sorted, and the first integer of the each row is greater than the last integer of the previous row. So 7 and 10, 20, 23. So 23 is greater than 20 and 10 is greater than 7. This is what the problem statement is. So we have to find a target which is 3 here for this case. If it exists, then we have to just return true, and if it doesn't, we have to return false. So it is a sorted list of list, or you can say 2D list. So sorted, whenever there is a key or hint is given as sorted, think it will be binary search. So what we can do, we can treat this matrix as 1D array. So how we will do that? We will treat this whole 2D list as a single list. So 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. If this was given as a list, and if we have given a 3, which is the target, so we can find 3, right, using binary search. Same thing we will do. We will write the code, we will do the binary search, and we will return if it exists or doesn't exist. So what will be time complexity? Time complexity will be big of log m multiplied by n, because binary search is log n, right? And because there is m multiplied by n number of elements, row and columns, so this is log m multiplied by n. And space complexity, it will be big of 1, because we will not use any extra space. We maybe use some pointers, but that's it. So we will declare two variables, row and columns. Row will be the length of matrix, and the column will be the length of the first index of the matrix, so first row, you can say. So we'll also need beginning and end pointers. So let's do beginning as 0 and end is row multiplied by columns minus 1. Why is that? We will treat this as a single or index 1D array. Okay, so end will be the last one too, because length minus 1. And let's do a while loop. We'll do the check here. If beginning, I think start is better than beginning. Yeah, sounds better. Start less than equals to end. So y equals to, because there might be a case where we have given only one element, so 1, so we have to return that element, right? So for that case also we will treat it like this. So we will find the mid as binary search suggests. We have to find the mid. So what we'll do, we'll just start plus end integer division of 2, so that we get the integer, and we'll do some tricks here. So R is the row for our mid element, will be index. So index is mid and division of columns, and column will be our index modulus of columns. So why is that? Why we are writing it like that? Because whenever we have to find index element, or like if we have, like we are given an index, we have to find the element in a 2D array. There is a formula. So the formula for finding element in a 2D array is like this: matrix, the index, I will write index as idx, divided by columns, and the column will be, this is the row part of matrix, and the column part will be idx modulus columns. So that's why I have written like R equals to this first part, and C column is the second part of the matrix. So we'll check if target equals to matrix, row and column. If it does exist, or if we find the target, we'll return true. And if target is, let's say, lesser than matrix, row column, so we will do what? Target is less than matrix row column means target is in the left side. So we have to change our ending point to mid minus 1, or else we can write like this: else start is mid plus 1, and if it doesn't exist, we just return false. Let's try to submitting this. Okay, it is accepted.